Okay, Tully, read me that equation. Y equals x over...
X plus 6.
All right. Which part do we care about more? Bottom or the top?
Bottom.
Yes, because that one gives you the what kind of asymptotes?
Vertical.
Vertical. And the vertical asymptote isn't just a number. It's got a letter. And I tried to help you remember. Vertical goes with a stupid word that'll help you remember it. So what is the letter? X equals, Rissy, you know the rest? -6. That is the vertical asymptote. X equals -6. And I have a friend who's a math teacher. And she was literally today telling me that her kid was complaining about how if I just say -6, it's the same thing. And she's trying to explain to him, no, -6 is a number. X equals -6 tells you which way that is. X's are vertical asymptotes. Okay, so this is a vertical one. It goes up and down at -6. That is way more info than just a -6. A -6 could be in tons of different places here. That is what that means. Okay, so there's the vertical. And then the horizontal asymptote. Greta, tell me that little trick we're supposed to do. And then what do you do? Because that doesn't really matter. 1,006 and 1,000 are pretty close. So then, final answer? Y equals 1. Nice job. And that is the horizontal, aka horizontal asymptote. It's just really common for kids to put them in the wrong spots. So by now that should be, I hope, pretty easy, because they're going to give you much trickier ones than that. You'll have to factor them, and once you factor them, it's not that bad. All right, then we went on to two different functions. F of x equals something. Let's do just x squared. And g of x equals square root of x minus 2. And we could just say to add them, but then you just write this plus this. Like, it's so easy. And yeah, we might even have one like that, but I'm not even going to bother with that because adding them is super easy. Subtracting them is super easy. You just put a minus in between them, okay? Multiply, still super easy, but some kids don't know, like, can you actually distribute this out? So you tell me. If I multiply them, can I distribute that in? Give me a yeah or a no by give me a thumb. You have to decide. Either yeah, you can distribute the x squared in, or no, you can't. Give me your opinion. All right now, I have 3 no's and 2 yeses. So obviously it's not super clear. That's why I'm talking about it. You cannot. Think of these as like in jail. The only way to bust them out of jail is to square it. Not to multiply it by x squared, but to square it. You can't get those out, so you just leave it like this. You cannot distribute the x squared into it. Okay? All right, so try to remember, those guys are in jail, and they're just going to stay that way. Again, if we wanted to square both sides, we could get them out. All right, so next, what if I asked you for the domain of this? Well, it would be based on the domain of the parents. It's very common for people to forget that, and it will come back to burn you if you don't know that. So would everybody please write the domain under each of these? Domain of F, domain of G. We had a whole test on domain. You can't afford to just forget domain. If necessary, make a little sketch. Then you'll be able to go left, right, that's domain. I gave you a shortcut for this, all reals. Raise your hand if you already knew that. Cool. The other one, I think the fast way to do it is not to sketch it. It's to go x minus 2 is greater or equal to 0. Add 2 on both sides, x greater or equal to 2. Raise your hand if you had that. Cool. Now, if I had asked you for the range, then this would have probably been an inverse problem. We aren't there yet. So far, I just asked you for the domain of it. So x is greater than or equal to 2. Are you with me so far? Now, the next kind of question that is the hardest kind, and for sure on the test, is what's f of g of x. Make the f function eat the g function. And then, what's the domain of it? Now it's dangerous for a teacher to just keep on teaching and not like seeing how you're doing. So in a moment, because it looks like you're all getting it and you're all fine, but maybe half of you don't even know how to do this. I need to get that feeling here by having you compare with the kid next to you, and then I get to hear things like, I have no idea, I'm lost, or whatever. Or maybe both kids look at each other and go, yep, I got the same thing, and then I can tell, oh, everybody's kind of getting it. All right, so that's one of the reasons I have you compare with the kid next to you. So some of you know how to do this, some of you don't. For right now, don't worry about the domain. Just what does it look like when f eats g, and simplify it as much as you can. All right, please compare with the kid next to you. See if you got the same thing.
If you square root it, it just gets rid of it.
Anna, can you put your phone away? If you were using it, I'd make you put it in jail. In your lap usually means you're going to use it when I'm not watching. All right, so here we go. F function is x squared. But then I replace the x with what it eats, which is this, square root of x minus 2. I did say the one thing that could break it out of jail would be squaring it. You see that? So this is just x minus 2. That's it. The squared takes off the square root. Those are inverses of each other. All right. So how many of you actually had that all the way down to x minus 2? Okay, most of you caught that. That's good. Now, would you agree that if you look at that, just y equals x minus 2, it looks like it has an unlimited domain. The domain is all reals. But that's wrong. All right, I'd like you to give the final domain. I'd do it as a number line if I were you. The domain is not all reals. Remember that you have a history. Your parents getting, having a weakness for something might cause you to. Maybe your parents have a heart valve that's weak. My sister had to have her heart valve replaced. Guess what I have to do then? I have to be checked for that because my sister's heart valve might mean that I also have that same heart valve issue. And I could just drop over one day because the heart valve has a weakness and boom, just gone. She had to have it replaced. So she's got this actual mechanical heart valve. And get this. You know what? When you're laying really quiet at night, you know what she can hear? Yeah, she can hear the heart going click, 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 click. Isn't that crazy? So she had to get used to it. And what I was telling her to try to, just a dumb thought, I don't know anything, but I'm like, that's the sound of you being alive. The scary thing now is if it stops. So the clicking should be like, good, 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 yay, it's still working. All right. Okay, so back to, this doesn't have any weaknesses, but we have to include the parent weaknesses. So 2 is the key number, fill it in, greater than 2. I get it. You might be like, but it seems like you can put in 0 and 1. I mean, you put them in and it's fine. It's because of the fact that it came from a function that would have that weakness. Okay, that's going to get a lot of people. A lot of people are just going to go, well, what's the domain of this? Nope. You got to depend on the 2 parent domains. Put them all on a number line. Okay. Then, yesterday I taught you about inverses. A lot of topics here in a row. Y equals 3x minus 10. Would you please try to remember how to do an inverse and make the inverse of this thing? Trent, tell me the basics. Like, what do I do first?
You put the y with the x.
Very good.
X equals 3.
And then you just solve it. I did tell you could either divide both of them by 3 or just divide it all by 3. Either one's okay. Think of it this way. If these two have a common denominator, then you could add them together. And you could make them one big fraction that has a 3 on the bottom. That's why that works. Okay, so there you go. X plus 10 over 3. What's that called? Hello. This is the topic called, starts with an I. Inverse. That's called the inverse. This is an inverse. Okay. Now, the other original function had a minus 10. We've got a plus 10. It had a times 3. We have a divide by 3. All right. So it's kind of like opposite world. X turned into Y. Y turned into X. And if I told you the domain of this was blah and the range of this was blah, they would switch. The domain and range of this new function. The domain would come from the range of the original one. So whatever this was, now it happens to be a really boring one because they're both all reals, but the domain becomes the range and the range becomes the domain. All right, so here's one that's not as boring. It's got a domain and range that are more interesting. So this is more typical of what we would test you on. Y equals x squared minus 9. Now I know my favorite saying is if you can factor it, you should. In this one case, I don't think it would help you. If we're trying to find the inverse, first find the domain and range of this puppy. Because later you'll have to find the domain and range of the inverse. So if you don't know the domain and range of that, sketch it. You should be able to go, oh yeah, I know what that looks like. That's a parabola. Okay, I'm going to pause for a second while you try this. And then I get to teach you the actual new stuff. So many topics. This is more typical pre-calc. Like almost new stuff almost every day. Okay, Sean, I'm going to make a little XY chart. Can you tell me what this looks like? A parabola that has been
Shifted to the right 9.
up, not to the right 9. I know what you're thinking. If it was in parentheses squared, if that was on the inside, it would be right 9. What was this one actually? Down 9. Okay. Brady, did you have one that was down 9?
Yeah.
Okay, good. So then you probably can tell me the domain and range a little easier because you had time.
Negative infinity, positive infinity.
Yep.
And then
Or you could have said all reals. And
negative 9.
-9 to infinity. Bracket or parenthesis on the -9?
Bracket.
Bracket. Very good. Now, without even making the inverse, I could tell you the domain and range of the inverse. Know what I mean? I don't even have to know what it is. I don't even have to switch x and y and solve it. I can just know the domain and range of the inverse. Please do that. And then, after you've done this function, because seriously, that will prevent you from by accident looking at it to find the domain and range. Just get the domain and range swapped right away. And then swap x and y and get the inverse. I'm going to get you used to this terminology. F of x with a little -1 on the f. That means inverse of. So find the domain and range of the inverse and then find the inverse. I'll pause for a second and then I'll have you compare with the kid next to you. Not quite yet. Okay, so x and y get swapped to find this inverse. So I'm going to replace this y with an x equals y squared minus 9. Then I'm going to add 9 to both sides. And I'm going to get x plus 9 equals y squared. And then I hope you knew to square root both sides. Because that's how you get rid of squared. They're inverses. So y is alone now. And it's equal to that. Now one more thing. I doubt there's anybody in the room that remembered this, but there's one more little thing. Anybody know? I'd love to know that you knew. Okay. This one is just a little fine point. When you square root a variable, when you put a square root on it, you end up with plus and minus that. So everybody slap in a little plus minus. On the test, I'm not sure if we do one that goes that direction because everybody would forget the plus minus. Let me give you an example. X squared equals 16. I square root both sides. When I do that, this becomes the absolute value of x is 4, and that gives you two answers. X equals plus and minus 4. Because, you know, one answer is x equals 4, and then the other split is x equals negative 4, see? That's what's happening. When you square root a variable, you get plus and minus it. So that would be easy to forget. Hey, you signed up for precalc. You said, I want the more challenging class. They wouldn't ever have something like that in FST. All right. So now what do we do? That's the inverse. That's the inverse of that original function. And that is not a function. Why is that not a function? Because it's got two equations. Y equals plus square root of x plus 9, and the other one, y equals minus the square root of x plus 9. So it's a small point here. I'm just trying to make sure you're getting the full experience. That is not a function because it's got two y equations. I did mention that on day one. That's one way to tell is that, you know, that vertical line test thing. Oh, not a function because it doesn't pass the vertical line test. Another way to tell is if you get two equations for y, it's not a function. Doesn't mean it's illegal. It's still called something, but it's not a function. It's called a relation. All right, now the last thing. And I think, honestly, this is our last thing before we test. Now, we still have some review days, but this is the last new thing, I think. It's called odd and even functions. And let's just give you some pictures for a bit because we've been doing a lot of heavy algebra. Everybody draw a V shape like that. Do you guys remember which one that is? Say it if you know. Absolute value, very good. So that's the absolute value function. That one is called an even function. If something's even, it means it's got symmetry across the y-axis. Like this. This one, this is even. So if it has the point negative 2, 2 on it, it would also have the point, be smart. What is that? What's over there? It's got to be there. 2, 2. What's the difference? Well, the x becomes negative. If you stick in a negative x, you get the same y output. See, whether I put in negative 2 or 2, I get the same answer of 2. Now, just looking at it as a picture, do you get that human beings have a line of symmetry right down the middle of our face? Therefore, we effectively are an even function because we have symmetry right down the middle of our face. We're even. All right? If you called your friend odd, it's not a compliment, right? All right, so what would an odd function look like? I'll show you. This one is an odd function. Anybody recognize that one? It's one of the more rare functions. It's one of the big 6 you're supposed to know, though.
X cubed.
X cubed, very good. That one is called an odd function. Why? Because it's got a different kind of symmetry. Do you get there isn't symmetry where there's like a point straight across from it? But there's a point kind of diagonal from it? So if this one has the point 3, 1 on it, this one will have the point, come on, think about it, what would that be? Yes. That's called odd symmetry. And the way we algebraically prove these things goes like this. If you put in a negative of the x, see this x was 3, and if you put in a negative of the x, you get a negative of the y. Do you get how these both were positive? And these are both negative. But you shouldn't think of it that way. You should think of this as the input. If you input a 3, you get an output of 1. If you input the opposite number, if you input a negative of the x, you'll get the opposite answer as you used to have. So if I have another point on this, and let's say it's like, I don't know, 5, 10, and I know that wouldn't actually be on x to the third, but just go with it. If that's 5, 10, then down here, there'd have to be another point of -5, -10. If I know this is on it, then I know there'd be a -5, -10. You put in the opposite of the x, you'll get the opposite of the y. Okay, so if I give you a picture, you're supposed to be able to tell me even, odd, or neither. First off, is it even? No. Is there a chance that it's odd? Yeah. I need a few points though. But if I gave you this point and I said this is 4, 4, and I also gave you this point and said it's -4, you put in the opposite x, and -4, then you'd be like, yep, that one is odd. I know it's not nice and curvy like the other one, but okay. It's got symmetry through the origin. Okay, here's one that I think you'll recognize that it's a certain kind. Oh, I made that really off. I'm going to try again. I missed again. Never going to be perfect, but okay, that's going to be good enough. Let's say that's 3, -6, and I tell you over here, I've got the point, well, you tell me. If this really is even symmetry, what's over there? Kai, what would be over there? Yep. And notice that we do the opposite of the x, -3, but we get the same y. See, the -6 is still -6. And we did the opposite x. Why do I keep saying it that way, the opposite x? Because there's, the way you prove things are algebraically even or odd goes like this. This is something you have to memorize. It's like a little tiny chart. Write this down. You'll have to memorize this. If you put in f of -x, you stick in the opposite of the x. If the y stays the same, would you agree f of x is actually called y? Then you've proven the thing is even. If you put in a -x and you get the normal y, that's what that means. You put in a -x and you get the normal y value, then the thing was even. If you put in a -x and you get the opposite of f of x, that means the opposite y. Take a wild guess from context clues what it is. Come on. Must be odd. These are the rules. And on a test, when you have to prove something's odd or even, that's how you're going to prove it. You're going to prove it by sticking in a -x. And if you stick in a -x and you get the same y, then it's even. We'll do a couple, but if you don't have this written somewhere, then you have no hope. Like, you have to have that. Because if you don't write that on the test, you don't get the credit for the proof. So, math has these things called proofs. And you only have to do one. I think it's all year. I think we have one test that has proofs on it. It's this test. This next test that you have has a proof. You have to prove something. Do you get that in a court of law? That's what lawyers do all the time, is they prove something. They can't just say, I think this happened, judge. They have to prove it. Okay, and then people judge whether or not you proved it. All right, so here's a typical proof. Y equals x squared plus 4. Now, first of all, f of x and y are interchangeable. Do you remember that? Y is the exact same thing as f of x. So I replaced my y with an f of x. Okay. Now I gotta prove that that thing's either even or it's not. And no, you can't just say, from the picture, I can tell it's even. Because you know what? I can too. It's a parabola, it's shifted up. Yeah, it's even. I can tell it's even. But how do you prove it? With math. This is a proof. F of negative x means I'm going to stick in negative x wherever there was an x. Do you remember me saying that the parentheses are a really big deal? That you should always replace your x with a parentheses. Please do that. Copy exactly what I have. You need to have that parentheses there. Been written for a while, so you're not caught up. You need that parenthesis where the x was. See, this is straight underneath that x. It's this x right here that I replaced with the parentheses. It's moments like this where the parentheses are critical, because do you get that negative 3 squared is different than negative 3 in a parentheses squared? They're different. They have a different answer. You have to have the parentheses. Okay, so here I made my parentheses point, but I'm telling you, tons of you are going to get that wrong because you forget the parentheses. Now, what are we supposed to put in? Well, it says right here, it's supposed to put in negative x. So do that. All I did was took this and I stuck a negative x wherever there was an x. See, I'm going to show you. Right here there was an x, then I put in negative x. Here there was an x, I put in negative x, but I have it in parentheses. And now, if I simplify this, f of negative x is still f of negative x. But that, would you agree that the negative gets squared off of it and it becomes just x squared? Think about it. No matter what that was, if there was negative there or not, it would be like there is no negative there. Now, do you see the original statement of f of x is equal to this? When I stuck in the opposite of x, I got the same original f of x. Even though I stuck in negative x, I got the same y value. So the last statement is f of negative x was equal to f of x. Because this is f of x, isn't it? That's f of x. And that's the proof statement I told you we had to memorize. And that's why you have to memorize it, is because that's how you end. And that is your proof. I just proved it's even. If you stick in negative x and the function is still the same, after you simplify it, it comes out to the same thing, then that thing's even. All right. Now I'm going to prove one that's odd. You guys all know that I just put that up, x to the third, and then I said it was odd. Right? But you can't just say, I'm going to draw a picture to prove it. Pictures aren't a proof. You know, if you went into court and you drew a picture of what you think happened, that's not proof. But here's how you prove it in math. You stick in negative x, just like last time. And then you replace the x with a parentheses, and then you stick in negative x. And now you simplify it. This is still negative x. And this one simplifies. Does the negative go away on this one? No. It's still there. But I give you this hint. Get rid of the parentheses now, because that actually will mess you up if you have them there. You're simplifying it, because even without the parentheses, it's still the same. When you're doing it to the third power, the negative doesn't cancel, so those parentheses You simplify them away. And now, what do you think I'm going to end with? The same exact statement as last time? No. Negative 1 times f of x. Do you get that this is exactly the negative, and then that is f of x? Like, see, it was f of x. That is called a proof. Now, you might feel like, well, I got everything in this unit except that one proof thing. I guess I'll just, get that one wrong. What always happens then is the kid will make one dumb mistake somewhere on the test, and then they also don't know how to do this problem, and then that means you can't get an A. You cannot afford to have any problem on the test that you go in and say, oh, that's too hard for me. This one's a little harder than the other ones. It's an algebraic proof. It's really not that hard, though. So let's try one more. Everybody write down f of x is 2x to the third plus an x. Now, I'm going to ask you to prove whether or not that thing is even. No matter whether I would have said even or odd, what do you think I would stick in right here? Thank you. And now, over here, I mentioned these parentheses are huge. And don't forget the other x. There are 2 spots that are in x right now. Rissy, what am I going to put in those empty parentheses? Negative x. See? Negative x. I'm just sticking negative x into the function. That's all we do in the first line. Now I simplify it. F of negative x is still f of negative x. Will this negative cancel out, or will it still be there? Still be there. But in the front, if you leave it in between, it'll look like minus x. Like you're subtracting it. We know it's times, so it's still times, so I put the negative in the front. Should this negative go away, or will it just be minus x? It's minus x. Now, I can now say with authority, is that really f of x right there? Is that the same as f of x? Exact same thing. No, that is not the exact same thing. So you'd say it's not equal to f of x, so it's not even. There. I just proved that it's not even. Why wasn't it even? Because look, right here at the end, this had to come out exactly the same as that, and it didn't. Okay, now let's say instead of trying to prove that this thing was not even, what if instead I was trying to prove that it was odd? Now that I know it's not even, do you get it might be odd? Then I'm going to erase this, and if this was different and they wanted me to prove that this thing was odd, then I would end with this. F of negative x is equal to negative, do you have a short-term memory? What's the other one? Negative 1 f of x. Is this really true? Is this the same as my function, except with a negative 1 in the front that would be distributed to the whole function? It is. That is. This function is the same as f of x with a negative in front. So this one's odd. Do you get I didn't have to change the proof at all? I just had to notice that it ended with a negative in front. You're either going to try it one way and say, oh, it's even, or the other way, it's odd. Is it possible that a function could be not even and not odd? Well, just think about graphs. Aren't there weird shapes that aren't even and aren't odd? Yup. So things can be neither. It's like if I'm looking at a shape Does it have even symmetry? Well, might, maybe. If it's like us, that has even symmetry. Does the thing have odd symmetry, like the same here and the same here? There are shapes like that. And there are other shapes that don't have any kind of symmetry. It's kind of like all over the place. So, there, you've learned about even, odd, and neither. Now, this is never going to stick unless you practice it. So, let's do the first couple of the homework problems together. Everybody open it up. It was an intense lesson today, I know. But we had to review 4 topics in a row, completely different than each other. Now, there's too many questions, for sure. Or the first thing we're going to do is skip the first page, which you got it yet? There it is, good. That whole first page, 1, 2, 3, 4, 5, and 6. Cross them all off. We're going to start with number 7. Would you read me number 7, Tully?
Yeah. G of x equals 2x to the 4th.
2x to the 4th?
Yeah.
And what does it want me to do?
State whether the function is odd, even, or even.
All right. My advice to you, first thing you do is stick in negative x. Unless you want to graph all of these, which would be, that takes a long time. Negative x goes in. Now you just have to simplify it. Always test for even first and just see, does that negative just go away? Does it? Yeah, it does. So I'm left with 2x to the 4th. Then you have to finish. If you don't have the last line, you don't get the points. G of negative x is G of x. You know, that's the same rule as we just had. It's just the G instead of the F. That's the proof that this thing is even. Once something's even, you don't have to prove that it's not odd. We already know it's not odd. It's even. There's nothing out there that is even and odd. You can't be. So if you proved it's even, like we just did, then that's it. You're done. Now, if we checked it and it wasn't even, then we'd have to check and see if it was odd. Get what I mean? If it's not even, then you can go, okay, I'm erasing the even, just the very bottom, just this part. And then I'm going to see if it's odd. And then you just check and see if you put a -1 in front. If it's the same, then it's odd. All right, so you check even first. If it's even, yay, you're done. Let's move to number 8. Arrow, would you read me number 8? X cubed. I already know it's odd. Can I just say it's odd? No, you have to prove it. Just like in court. You can't just say, I know the guy's guilty, so you have to prove it. All right, so I'm going to go h of negative x is equal to, I just put in a negative x in both spots. The third line is simplify it. So does the negative go away or does it stay? It stays. And then you have to end with one of those lines. H of negative x is either equal to -1. Now, I'm not even going to try to bother to prove that it's f of x because it's not. It's the opposite. So I'm not going to end with that one. I'm going to jump right to the odd one because I know it's odd. So I'm going to go -1 times f of x, except this is h of x. That's the proof line right there. If you get to there, now you can say odd. Get out to prove these things are even or odd? All right, that was the last thing. Now you just have to review this for a bit on Monday and Tuesday. Maybe Monday, just Monday, and then test Tuesday. Or it's Monday, Tuesday review, and then test Wednesday. It's something like that. I'll know for sure on Monday. All I know for sure is that right now, you need to do problems. It says actually right in the title of the worksheet which problems to do. I think it was 7 through, what was it? Did anybody read the title?
7 through 10 and 13 through 15.
7 to 10, 13 to 15. There you go. There's your problems. Okay, don't underestimate this. It's a weekend. You tend to forget stuff on the weekend. You need to do these to practice it or it won't stick. When you come back on Monday, you'll be like, I don't remember how to prove something's odd or even. Practice it. Yes?
How do you know when it's neither? Like,
If you
after-
tested that it was even, and the answer was no, it wasn't even, and you test for an odd, and then you're like, no, it's not odd, then you've just proven that it's neither. Okay, cool. That's all I got for the video for today.